Hi, everyone, and welcome to our webinar diving into model-based testing. I'm Tonislava Docheva, Product Marketing Manager at Xray, and with me today I have Ivan Filipov, Solution Architect at Xray. We're very happy that you're joining us to discover more about model-based testing, and we hope you can take some valuable insights from this presentation. We decided to bring out this topic because we believe that the implementation of a formal model-based testing program can be very beneficial for companies that are looking to improve their quality engineering practice. Although embracing model-based testing has a learning curve and setting up takes some dedicated time, it can be very beneficial as an investment at the end, as it can improve collaboration among internal stakeholders, help you gain a more complete understanding of the system under test, and ultimately increase the efficiency of your testing and development teams. Let's jump right into our agenda and what you can expect from today's webinar. To start with, we will set the tone with a definition of model-based testing. As there might be differences between how people view model-based testing, we'll give you our understanding and start building from there. Then we will briefly discuss the history of model-based testing and give you a glimpse of where it can go in the future. Next, we will dig into some of the more common modeling techniques. Model-based testing comes in a variety of formats, and today we'll try to cover a few of them and how you can build different models to cover the same application from different angles. At the end, we'll have time for a 15-minute Q&A, so feel free to submit your questions in the right side panel, even during the presentation, and we will do our best to address them all at the end. So let's get started. I'll pass the word over to you, Ivan.
Thanks, Tony. Quality engineers often create mental models of the system under test as a way to understand software better. We then use the models to facilitate discussions and also to perform actual experiments on the application. But what exactly is a model? And how do we effectively create and use it in quality engineering? The concept has been around for a while, so there are various definitions. We will focus on these characteristics they have in common. A model is a simplified, more abstract representation of the desired behavior for a system under test. Each model has a well-defined scope, for example, get an insurance quote, that focuses on capturing the key aspects and dependencies of a given application segment. Further, models have a clear structure, although the forms are quite diverse. The element types that most formats share are inputs, states, and expected outcomes. Last but not least, the approach is quite subjective. If you ask several domain experts what they think the optimal model is for a given application, the answers will overlap but won't be the same. That is why it is crucial to establish a collaborative environment with early stakeholder involvement from different teams to integrate diverse perspectives. As a side note, it is important to keep in mind that the different ways tests can be derived from a model are not part of the model definition. In some situations, they can be almost synonymous. For instance, flow diagrams and all edges or all nodes test generation methods. And yet, test derivation algorithms are a separate topic. Now to talk about the key implementation aspects. Formally and consistently leveraging such models in the quality engineering process is referred to as model-based testing, often abbreviated as MBT. Given that it is a systematic and iterative approach, let's take a look at the core steps to perform it. First, it's necessary to analyze the requirements as well as any relevant domain knowledge, and identify critical variation factors affecting the outcomes. Second, you should create the models by assigning the factors from step 1 to the respective elements based on your technique and format choice. The third step is to identify and apply the optimal algorithmic test generation method, ensuring appropriate model element coverage for different system behaviors. The method may change throughout the project lifetime based on your goals. Finally, you can execute those tests and analyze the reports. Understand the impact on the model, maintain it, and iterate for the next execution cycle. It is important for the feedback loop to go all the way back to the model and requirements level, not to the individual generated tests. Next, let's talk about the reasons why MBT can be worth your attention. Business requirements, especially for complex modern systems, can be quite ambiguous and spread out across numerous sources. And the typical approach is to create tests manually from each requirement, which often exacerbates the lack of clarity. Contrast that to building a model based on multiple interrelated requirements and sharing it as a common ground artifact early in the process. Ambiguity can be significantly mitigated. Second, it can enhance coverage and early defect detection. Traditional testing methods have a higher chance of missing critical scenarios or edge cases due to the fragmented approach. As a result, the likelihood of unexpected issues not surfacing until the app is in production jumps dramatically, exponentially increasing costs and possibly damaging reputation. On the other hand, MBT offers a more comprehensive approach, making it easier to identify problems even during the requirements definition and test design stages, and reducing the costs of fixing defects. Third, centralized maintenance and impact analysis lower the level of inefficiency. Since test cases are derived algorithmically, any modifications at the model level can be immediately incorporated into the whole test suite, removing some of the repetitive and labor-intensive tasks. Also, MBT boosts reusability and consistency, since it is easier to repurpose the model for regression or new requirements, while all the generated tests will be in the standardized format. All those strengths act as a catalyst to the last major advantage, which is a shorter development cycle and faster time to market while maintaining customer satisfaction. Because MBT facilitates quick feedback loops and continuous testing, it works well with the agile and DevOps approaches. Let's take a brief walk down the memory lane and then discuss the future possibilities. The approach is not new. The concept of MBT has existed since around 1970. The research field is rich with papers on the topic, and it is still evolving, with discussions around the nuances of techniques and the adjustments for the modern level of complexity. In practice, certain industries have historically taken more advantage of MBT, for instance, aerospace and telecommunications. And yet, we can't say that MBT has really taken off in popularity. Quite a few studies mention that it cannot be considered the mainstream approach for quality engineering given adoption levels. Why is that? What are the missing pieces of the puzzle? Let's review some of the shortcomings that we hope the further evolution in this space will address. First, the initial investment can be quite high, and the tool licenses are not the main factor. MBT requires a mindset shift and puts a higher emphasis on skills like critical thinking and on the availability of domain experts. Finding the time and resources for such personnel development is often the main adoption barrier. AI in testing is quite a hot topic, and the use case of generating test cases from requirements makes sense as the entry point. However, it will just partially mitigate the disadvantages of the fragmented approach instead of just revolutionizing the field. Making AI build models and act as a pseudo-domain expert in pair testing techniques would be one of the ways to address the first shortcoming. In the meantime, we have a blog article with some tips for modern skill development. Second, it can be challenging to find the right balance between abstraction, which can be too shallow for practical use, and execution, which can get very bloated. While clearly defining the optimal scope would still often fall to the humans, it would be helpful if the tools could streamline that transition from, let's say, mid-level abstraction to full execution readiness. Staying with the tool angle, there can be a bit of choice paralysis in the current market. Trying to pick the tool that does the right type of model techniques for your use cases, worrying about potential migration and conversion down the line, none of that is particularly appealing. Hopefully, in the future, the tools will demonstrate more versatility and streamline the MBT implementation. Lastly, some of the potential disappointment with model-based testing is avoidable if the expectations are not influenced by misconceptions. Model-based testing does not replace all other testing methods, like exploratory, performance, or usability testing. It complements them. While MBT accelerates multiple tasks throughout the test design process, it is not supposed to completely eliminate human involvement. Collaboration with stakeholders is always crucial. Related to that, adopting models as your key artifacts by itself does not trigger a magic switch of sorts and automatically guarantee perfect coverage. Continuous reviews and updates are critical for maintaining model effectiveness. Now let's talk more about the practical aspects. We will do a brief overview of popular modeling techniques, then show sample implementation for the 4 in bold on a shared use case. To start with, state transition tables are one of many ways to describe a system with the finite number of states and deterministic, non-concurrent transitions between them. The focus is on validating the correctness of the system behavior in each state, as well as during those transitions. Next, there are many visual types, for instance, state charts, activity diagrams, control flow graphs. Unified Modeling Language, or UML, is a common way to implement them. It fosters a standardized, holistic visual approach that is crucial for applications with robust structural or behavioral requirements. Activity and use case diagrams, sometimes also called business process flows, depict how users interact with the system components or other users, laying out the sequence of actions, decision points, and concurrent activities. Entity relationship diagrams are frequently leveraged in database design to showcase the relationships and data structure between various entities. Control flow graphs show the order in which the code is executed. Data flow diagrams demonstrate how data moves through a system with an emphasis on its entry, processing, and output. They are helpful in confirming dependencies and transformations. Next, decision tables excel in modeling systems with numerous conditional rules by providing a structured, tabular representation of decision logic. Decision trees is another popular variation. Variables and rules can be considered an offspring of decision tables. We will talk more about its characteristics during the sample implementation. Lastly, Markov models are used to display state changes that are driven by probabilistic rules. They are employed in system performance and reliability analysis, as well as modeling stochastic processes. Networking protocols are a good example. On to the sample implementations, we will talk about a hypothetical e-commerce platform, and for several requirement groups, we'll see which modeling technique can be an optimal fit. Here we have a simplified list with some of the new acceptance criteria for the user authentication flow. We can notice that the transitions seem sequential, with the point-to-point progress based on the well-defined trigger with finite options. Those characteristics bring state transition tables to mind. So let's see how it could look like. We can track the process from left to right, starting with the first row where a logged out user clicks sign in to initiate authentication. From the authentication state, we can have two mutually exclusive transitions dependent on the credentials. Sometimes the error message piece is moved to a separate column to better highlight that the state overall doesn't change. The technique does a decent job of comprehensively capturing this kind of a requirement set, outlining the key stages in the process and what is expected to happen in between. For the weaknesses, state transition tables can struggle with more complex, concurrent, or non-deterministic behaviors. For instance, once we start looking at more possible ways to provide credentials, like single sign-on with different providers and more robust error testing, the table can become a bit unwieldy. For the second example, we have an adjustment to the order processing system. We can see sequences of more than two actions, as well as potential for concurrent or back and forth activities. If this requirement set was simpler, state transition table would still be a viable option. But for this use case, a behavioral UML diagram is a better choice. For example, it could look something like this. In a single artifact, it allows us to clearly visualize related flows, regardless of their length, key choices and their consequences, whether those are concurrent or mutually exclusive. Here are the loops from the second acceptance criteria, and here is the exit point from the first one based on two decision nodes. For the weaknesses, the required expertise is a bit higher given proficiency in UML and likely specialized tooling. Also, sometimes understanding the rules from just the diagram layout is challenging, especially when we analyze possible connections between non-neighbor elements. If a node has 3 incoming lines and 2 outgoing ones, that does not automatically mean that each incoming path can transition to either outgoing one. Or in this example, it could be difficult to visualize a rule like when corrective action is taken and post-processing is yes, then packaging should include extra disclaimers. Next, we have the discount system upgrade. We can notice the pattern of when-then logic with the same factors interacting in a predictable manner. Doesn't look like the process is lengthy or branching out in many different directions. That prompts us to consider a decision table. It usually has 3 sections: list of conditions or triggers, in our case 2, list of outcomes, in our case 1, and the rules bringing the 2 sections together as columns. At first glance, it may look similar to state transition tables, but notice that conditions are simultaneous, not sequential, and we expect more interaction freedom. Some of the key advantages are easier traceability, since rules closely match each acceptance criterion, and more systematic logical analysis to identify gaps or contradictions in requirements. For the weaknesses, unlike the previous 2 techniques, decision tables do not provide a good overview of the process. In other words, if we were not generally familiar with e-commerce, we couldn't deduce the role of discounts in the overall user experience from just the decision table. It is laser-focused on the specific areas of the application. Another good example is rule engines for insurance or mortgage applications. Therefore, this technique is less independent. And the other potential barrier is scalability. When a system has a huge number of rules, each with a different number of conditions, it can take a lot of time to accurately specify all explicit possibilities in the tabular format, and you will likely need more than one table. Last but not least, we have the variables and rules technique. You can think of it as an offspring of decision tables. We won't give it a requirement group because one of the key advantages is versatility. Instead, we will show how the previous use cases could be implemented with this technique. The idea is to put conditions or triggers or states or decision nodes in one array-like entity and their rules in the other. While having 2 artifacts has its drawbacks, it can also simplify review and maintenance. This is the technique used in Xray Enterprise Test Case Designer, so we will take the screenshots from that particular implementation style, and we'll use the terms parameters and variables interchangeably. For the first sample, as you can see, we have a parameter per possible state and action. Then 2 rules controlling possible state transitions. Overall, this technique can have an advantage over state transition table dependent on the number of states and the variety of possible events that could lead to transitions. Limited selection of states with one possible event each is not a very good use case. There are several forms for the variables array. Lists, mind maps, or APA data dictionaries are popular examples. Rules are typically in the list-based format with declarative, business-readable syntax. For them, one of the key distinctions from the decision table approach is that we focus on what cannot happen rather than what can. Typically, that represents a smaller set of possibilities, so you save time on the implementation. However, that inversion could be tricky in the early stages of adoption. For the second sample, the diamond decision nodes are the core of the parameters list. Rectangles can be incorporated into values dependent on the significance. While not as visually clear, you can still understand the flow sequence from the parameter order. From these two examples, you can notice that one of the shortcomings of the variables and rules technique is dealing with the flows of drastically different lengths. To an extent, you can address that with extra values like NA or blank and the corresponding rules. In general, especially for large systems, do not expect to fit the entire diagram in one test case designer model. On the other end of the spectrum, diagrams that do not have 3 or more diamond nodes may not be a good use case for test case designer. For the third sample, we wanted to show a mind map representation of the variables. Also, notice that the first two rules are clear examples of how we focus on what cannot happen. For instance, we say that new customers cannot get the loyalty discount, instead of saying that they can get one-time, non-stacking extra, or no discount. Before moving to the conclusion and Q&A part of this session, I'll briefly summarize the consideration for choosing each option. State transition tables excel in tracking sequential events in relatively simple applications. UML diagrams, specifically behavioral types, are great for visualizing flows of different types, with hierarchy and timing coming into the picture. Decision tables are a good supplemental technique for detailed logic analysis, and variables and rules is a jack of all trades, giving you the flexibility to apply the same approach to various use cases. The techniques are not mutually exclusive. You can choose multiple even for the same set of requirements. For example, activity diagram for highlighting the overall flow, then variables and rules for diving into the interactivity scenarios. Tony, over to you.
Thanks, Ivan. Let's wrap up here. Here are a few of the ideas we would like you to take home. A model is a simplified, more abstract representation of the desired behavior for a system under test. Keep in mind the steps to perform model-based testing. First, analyze your requirements and identify critical aspects of the system. Next, create your model based on the information you collected. Then choose how you will test your model with manual or automated tests. Then execute those tests. And finally, understand the impact of the model, iterate and repeat. Remember that each type of model can fit more than one use case, so take your time to experiment what's best for your organization. There will probably be at least one modeling technique that fits your specific needs. If you want to get started with model-based testing, You can use a feature from Xray Enterprise called the Test Case Designer, which helps you implement the variables and rules technique of model-based testing. You can upgrade your Xray instance and start a free trial of Xray Enterprise today. We hope you've learned something new and useful about model-based testing, and we encourage you to experiment and try model-based testing for yourself using the Test Case Designer. And now let's move on to the Q&A. All right, Ivan, are you ready to answer some questions?
Yes, hopefully. Um, let's start with two from Vincent. Uh, Good market knowledge, good questions. First one, I'll read them in the other order, actually. First one was, what are Xray capabilities in model-based testing, specifically compared with Curiosity or Jest? And the other one was, the MathWorks graph we showed a little bit earlier is known for their model-based systems used in engineering, automotive, and transport. What are the practical solutions for IT systems? So for just a brief summary of Curiosity first, to get us on the same page, it is a model-based testing tool, and it works with UML diagrams primarily as behavioral structures, and then allows you to build any type of diagrams, import, etc., and generate test cases from it in an algorithmic method. List some of the options that are available there, what we mentioned with all edges, all nodes, kind of techniques. And so on the Xray side, the model-based testing capability, as we discussed, is Test Case Designer. It does allow you to implement only the variables and rules approach. It also supports several ways of building the variables list, whether it's direct typing or import or mind map import. And you can also incorporate the scripting capabilities in there, either in a manual format or the Gherkin format, which in some flows can be your starting point. Other than that, both tools are pretty strong. They both support the rule definitions, and one could argue in the variables and rules technique that implementation is maybe a little bit more streamlined, but you can obviously just take a free trial of Test Case Designer and find it out for yourself. Or if you have any follow-up questions or like a deeper dive demo into that tool, we'd be happy to address that as well. And then on the practical solutions for IT systems, first, just overall, the goal and the quote unquote dream goal benefits would still be the same as displayed in that MathWorks graphs. We want to find more defects early. We want to make our production experience as smooth as possible. And the techniques as well, they are relatively industry agnostic. It just so happens that MathWorks works with those three a little bit more. And some of the industries historically just have been more receptive, but it doesn't mean you simply cannot use some of those lessons in an IT industry. If that hopefully makes sense, if not, feel free to submit a follow-up question, or as discussed, can set up a separate demo.
Thanks, Ivan. I see we also have some more questions here. One from Charles, asking, does Xray Enterprise include a flow charting tool?
Good question. Not at this time. You can import mind maps specifically into Test Case Designer, but not UML diagrams. As a side note-ish, we mentioned AI, how it could be useful for MBT, and actually the very next feature we are working on for Test Case Designer is that kind of AI assistant. And at that point, you could provide UML diagrams to that assistant so that it could process it, convert it to a different technique, and help you move forward with that approach. But we're excited to talk a little bit more about that, hopefully showcase it in one of the upcoming webinars. But as of today, the answer is no. And also I see there was one more from Lenny, I believe, about the example of testing in the requirements gathering and design phase. Let's see. Well, at least one. For instance, let's say we are switching the industries a little bit from the previous example, and we are working on an insurance application. And we have a rule that is stated as an acceptance criterion in the requirement story that seems very straightforward. Let's say it is, if the named insured and the driver don't match, there should be an extra question displayed. Doesn't matter which question. Sounds relatively straightforward. So if you don't apply that extra analysis, if you don't think about model that would be related to this, you could let this rule be implemented by the developers the way they understand it, and then eventually later you might find problems. Alternatively, you can start building a model right away, and you can identify your key inputs. So those could be primary insured, secondary insured, the first driver, and the second driver, right? At the minimum. You can obviously expand it if you are doing more drivers or more possible insureds. And then you can arrange the decision table talking about the combinations of those four inputs and what exactly can and cannot happen and when exactly is that question displayed, right? So then you can start finding your ambiguities or potential conflicts pretty much right after that requirement is written. And so then the development team knows what are the specific limitations of the logic they need to implement, and you avoid finding issues a lot later in the process. Hopefully that example makes sense and answers the question sufficiently. But again, if there are more specific cases of your requirement style, we could be reviewing them in a kind of separate follow-up demo.
Thanks, Ivan. We have some other questions around from Isaac asking, which model would you suggest to use for exhaustive testing? This
That
is
is a
more of
good
a specific
question.
use case.
Yeah. I would say that's still a little bit dependent on the system, the underlying system. On average, in my experience, either UML diagrams or variables and rules, because they can fit quite a lot in a single instance of an artifact. And that would sequentially allow you to do a more exhaustive test generation from that single artifact. Because, as mentioned, decision tables are generally a supplemental technique because they don't give you as much space and methods to implement certain variation factors. And state transition tables are struggling a little bit with scalability, especially when the rules are a little bit more complex. So it is between UMLs and variables and rules, and then it just depends on the exact structure of the system, or more specifically, the structure of the scope you are choosing for that particular model given the system. And let's see. There were two other questions from Charles. One about automate the tests of test case. How do you automate the tests of test case designer? And the second one is, how is mind map imported? The second one is a little bit faster to answer, so it is in the OPML format. As of, again, today, it is just OPML file import, and it represents the mind map, and it does extract the data in a sense that it builds the parameters list from the mind map automatically, so you don't have to double your work. However, with that AI assistant, that kind of import would be more robust in terms of data structure, data extraction, sorry, and also potentially the variety of formats that mind maps could come from. And the automation, it is a little bit up to you. There are generally two flows that our clients follow. One is where you generate the test data table. So you're focusing just on the interaction of the data, and then your automation framework is built for the data-driven approach, where you then export the CSV from test case designer, push it as a data source to your automation framework, and then all your script development just lives in that framework however you would like to do it. And the second approach is where you do script Gherkin inside test case designer. You then export feature files and again push them into the automation framework, provide the definitions for the keywords, and move from there. And the scripting part is up to you and also specific to you. We don't enforce any kind of syntax rules or limitations other than just connecting the script to the data table.
Perfect. Thank you for answering that, Ivan. We have a question here from Torsten, which I can answer. He's asking if we can say something about upcoming features. So we'll actually be having another webinar upcoming on December 18th, and there we'll be able to give you a little preview as to some of the features and concepts that we will be having in the next year. So stay tuned for that. And let's move on to some other questions, Ivan.
Absolutely. We next have from Michelle, according to your experience, how much time an average tester in IT takes to use your MBT tool correctly? Would say 2 weeks. And that is under two assumptions. One, they do get a little bit of semi-dedicated free time from their management to support the adoption, right? If it's just something on the side that they are maybe struggling to find the time for, obviously longer. Second, a relatively good knowledge sharing structure inside the company, because we do provide certification courses, we do provide uh, tutorials and documentation and things like that. However, the models are, as we said, context specific. So if the testers have a little bit of internal support in terms of sharing best practices, maybe having already collaborative examples built as samples that they have access to and they can learn from more directly, that accelerates the process. If they don't, again, we're starting to go a little bit further than 2 weeks. All right, and the next one from Anonymous. Which model do you think provides the most clarity for new testers? Recent joiners have been confused due to the amount of states we have been testing in. A little bit of a ironic answer because typically the state transition tables would be a little bit more on the clarity side. So I guess 2 points to the answer. One, could try UML diagrams just because maybe the lack of sequential clarity is the main blocking point, and that could help your recent joiners be a little bit more understanding of what is going on. The second one is, while not super recommended because the maintenance could get a little tricky, but you could apply the two-step approach, where first you have a higher level model, which simplifies the process maybe too much, but it provides the faster insight specifically for people that are a little bit newer. And then there is a deeper model that is a little bit closer to your execution level, as well as the people who have more experience on your team. And then they kind of see the transition a little bit easier, and then they hopefully understand how that second level of the modeling was done, and that helps them with the confusion. But from the clarity standpoint, again, keeping decision tables for their dedicated use case. Typically, the state transition tables are probably number one, UML diagrams probably number two. So you might have to address the scope a a little bit more than the format necessarily. Hopefully that answers.
All right. We have several questions from Satish. Ivan, I'll answer the first two questions and you can maybe tackle the last one. It's more feature related. So Satish is asking if we have a demo of how model-based testing works in action and where can we sign up for the upcoming webinar. So we will be sending a follow-up email to this webinar where we will share more resources of how model-based testing works in action. We have tutorials, YouTube videos that we'll be sharing. And for the upcoming webinar, we'll also share the date so that you can sign up and take a look at that as well. Do you want to take the last question, Ivan?
Sure. So the question for everyone is, Satish's team already has the Xray Enterprise license, and they would like to know what features related to MBT are included for them to explore. So for that, I'll actually just share the documentation links. First one just points you to the general overview of Test Case Designer, including the setup, how to make sure that that feature is available to the end users. There is a little bit of a setup. And the second link points to our collection of tutorials, some of which provide the end-to-end examples of how you would apply specifically the Test Case Designer process to different industries. So, but overall, that is the feature. There are features supporting it, supporting your other aspects of test management and QE, but specifically for MBT as of right now, Test Case Designer is that feature that you would be looking for.
Perfect. Thank you so much, Ivan, for clearing that up. Shall
And
we move to the next questions?
I believe so. Let's see, we have, I believe, two from Piotr next, right?
Mm-hmm.
So the first one is, are you planning any showcase of the complex setup on Xray with multiple different projects, many test streams, and what would be the best approach of test reporting in that complex setup, as many current options are not working, for instance, gadgets in Confluence? I don't think it is a planned topic for any of the upcoming webinars directly from what I'm aware of, and also doesn't seem like model-based testing would be necessarily the part of that conversation. So my suggestion would probably be to reach out to support and help set up a customized call and or demo to walk through that in more detail, because also dependent on the licensing type and the deployment type between the data center and the cloud, Xray Standard, Xray Enterprise, that could be slightly different cross-project options. So we would need a more dedicated call or support thread to dive into your specific question. And the second one is how to integrate unit testing in a setup of Jira and Xray. Is there any plugin to see coverage, etc., to not create items per every unit test? Because it makes no sense having hundreds of them. Having them in one place, not to go to SonarQube always. Off the top of my head, I don't think there is a quick way to avoid the item per test challenge, because you would import the results of your unit testing, but that would create, in most cases, an item per test so that we can then provide the traceability and coverage reports that count the items correctly. But similar to the previous question, we would probably want a separate deep dive into that issue. And I can double check what else we have, also maybe more specific to the SonarQube integration.
Yeah, exactly. Piotr, if you want, please reach out to support explaining your question, as you'll be able to get a more personalized answer for that. But thank you so much for writing in anyways. Um, I'm seeing we have one anonymous question, Ivan, and it's more related to AI. So the question is, how far do you think we are from AI applying model-based testing?
Hopefully not too far. Would be great to have the progress in that area. Uh, I think even right now, there are certain foundational models that maybe don't get as much publicity, but they are a little bit more focused on the critical thinking, advanced reasoning, those kinds of aspects. The Claude family is one of the examples. And as mentioned, this is the very next feature that we are trying to address for Xray Enterprise Test Case Designer with already some internal progress and reviews. So with a little bit of luck, we are very excited to discuss and show more in the upcoming webinar.
Exactly. Um, we just have time for one or two more questions. I see that there's some anonymous ones. Do you want to see which ones you'd like to have a go at, Ivan?
Yes, just give me a moment. All right, so one of the question is, how many requirements are supposed to go into one model? Um, that is a good one. I'm afraid there is no right answer. It is highly dependent on the way or the style that the requirements are written, which modeling technique you would like to use, and also your desired level of abstraction. Because in some clients and some implementations that we've seen, quite a lot of the heavy lifting is pushed to the execution side, where there is a lot of custom code and things like that that take abstraction and then convert it. On the other end of the spectrum, many clients prefer to keep their execution and automation more simple, which means that their models have to be as ready as possible, right? So that limits you a little bit in terms of how much you can fit into a single artifact. So overall, we can recommend performing some variation of mini clustering analysis first, based on the involved factors. And if you are using a requirements management system, something like Jira, then you should have certain metadata elements that could help you in that clustering, fields like label, component, things like that. And then as you start building a model from one cluster, just take a temperature check that is pretty specific to you and your company. See how comfortable you are with the current size, if you would be able to fit anything more, and then just make a judgment call. It's, as mentioned, the process is iterative. It's not like you build a model that is maybe too small or too large and you're stuck there and you cannot make any improvement. You can always make small tweaks to both the size and the level of abstraction. And maybe the last question, unless we have any more new ones come in. Okay, looks like no. Then the last question is about the scalability point. And it may be a little bit counterintuitive when we say that we have two artifacts in the variables and rules approach instead of one, and yet the scalability is mentioned as one of the strengths of the approach. So could you please elaborate? First, for the avoidance of doubt, the benefit points apply most of the time. Obviously, there can be edge cases with different experiences. And second, the scalability advantage is possible for variables and rules because there is a lower multiplicative impact on the total scaling. So for example, if we have a decision table and we get a new value and a new rule, both of those factors influence the growth of a single artifact, right? As we add columns for the new value in the old rules, plus we need to find the impact of the second update and then add or edit columns accordingly. And then with the variables and rules, those two factors affect two separate artifacts. So the total, let's say, cumulative growth is a little bit more contained. And again, coming back to the earlier points, on this rule set specifically, since you are focusing on the more negative space, what cannot happen, typically you don't need to add as many things. And maybe the last point on that question is, in some variations, again, more specifically for decision tables, but also for UML diagrams, one of the ways to deal with that growth problem is you specify any instead of actually listing the possible values and add in a column for each, which obviously does solve the spacing problem and the growth problem. However, it then hurts you on the clarity side because somehow each stakeholder needs to know what is underneath that any option, right? Both for the review purposes, the test generation purposes, and for the overall model maintenance. So maybe a more accurate wording for the slide would be that the variables and rules have advantage in scalability versus clarity balance, rather than maybe scalability as a standalone metric. And for UML diagrams, the reasoning is pretty similar.
All right, thank you so much, Ivan, for that detailed response. Just before we wrap up, we have one question from Kieran asking if it's possible to run Playwright automated tests. The short answer is yes. And the best place to find more information on how to do that is our documentation. I don't know if you want to add something to that, Ivan.
I believe in the second link, I may be slightly wrong, but in the second link that I shared about our tutorial section, there is a subsection about using Test Case Designer with automated frameworks. It is under real-world use case overviews. And there is an example for both Cypress and Playwright, if I remember correctly. The article should be called How to Optimize Data-Driven Automation with Test Case Designer.
Perfect. Yes, Karen. So feel free to check out that link and learn a little bit more about how you can use Playwright tests. I believe that's all the questions we have, and we're just about out of time. Ivan, thank you so much for the presentation today and for addressing these questions. It was great to have you on board explaining a little bit more about model-based testing. Thank you as well so much to everyone that attended. We really hope you had some useful takeaways around this topic. As we mentioned earlier, you can use the Test Case Designer feature from Xray Enterprise to implement the variables and rules technique of model-based testing. And if you want to try the Test Case Designer, you can upgrade your Xray instance to Xray Enterprise with a free trial. We'll be sharing a link in the chat shortly for that. And we'll also be sending a follow-up email with the recording of this presentation if you want to share it with your colleagues. And we'll be sharing some additional resources about model-based testing. So keep an eye out on your email for that. That's really a wrap for today. Thank you so much, everyone, for joining us. And we're very excited to see you in our next webinar. Thank you so much.
Thank you.